Now if we have two charges Q1 and Q2 separated by a distance, 2-point charges Q1 and Q2 separated by a distance R, then we can find the magnitude of the force between these two charges. And if these two charges they are placed in the free space or air, then according to Coulomb's law that force will be equal to 9 into 10 to the power 9 Q1 Q2 by R square. Or if it is placed in any medium, then this F will be equal to 1 by 4 pi epsilon. This epsilon is the absolute permittivity of the medium, Q1 Q2 by R square. So by using the formula of Coulomb's law, we can calculate the magnitude of the force between the two charges. Now force is a vector quantity, so it has got magnitude and also direction. Now in this formula, what you see is just the magnitude and not the direction. Okay, we have only the magnitude of the force from this formula. We can calculate only the magnitude of the force. But since force is a vector quantity, we can express Coulomb's law in vector form also. So how will we express Coulomb's law in the vector form? So to express Coulomb's law in vector form, we will use a unit vector. Okay, we will use a unit vector. Now what is a unit vector? A unit vector is a vector which has a magnitude of 1 unit only. It only gives you the direction. Okay, so you can use a unit vector to indicate the direction. So let us take, for example, let us consider, say, assume that we have Q1 here to be positive, the charge Q1 to be positive, and the charge Q2 to be also positive. So since both these two charges they are positive, they will experience a force of repulsion, which is given by Coulomb's law. And if they are placed in the free space, then that force is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, where R here is the distance between the two charges. Now I want to express this Coulomb's law in vector form. So what I'll introduce is a unit vector. So what I'll do is I'll draw a unit vector from Q1, and this unit vector will be in the direction from Q1 to Q2, and this unit vector is say R cap, in which direction it is? From Q1 to Q2. So we have R cap 1, 2. Similarly, I draw another unit vector which is R cap, in which direction? From Q2 to Q1. So we have R cap, I'll write here subscript 2, 1. So here we have 2. I have drawn two unit vectors. One is this R cap 1, 2 in the direction from Q1 to Q2, and another is this R cap 2, 1 in the direction from Q2 to Q1. So now I can express this Coulomb's law in vector form for these two like charges Q1 and Q2. So the magnitude we know is 1 by 4 pi epsilon naught Q1 Q2 by R square. So this is the magnitude. Now the direction. Now again here for this force, I shall express this one in the vector form. F vector, and say this force on Q1. So this force is a force experienced by the charge Q1 due to charge Q2, or force exerted okay, on the charge Q1 due to Q2. Then again another one here, the force exerted on the charge Q2 due to the charge Q1. So here Q1 will exert a force on Q2, and that force in vector form is given as F21, and Q2 will exert a force on Q1, and that force is given as F12, force on charge Q1 due to Q2, and F21 force is read as force on charge Q2 due to charge Q1. So this is the force in vector form. So here also I'll write, suppose I'll take this F12, so F vector force on charge Q1 due to charge Q2. Now the magnitude is this, 1 by 4 pi epsilon naught Q1 Q2 divided by R square. What is the direction now? What will be the direction of this force F12? Now to know the direction, we'll have to look at the unit vectors. Now unit vectors, they only specify direction, they don't give you the magnitude. The magnitude is 1 unit. So here we have to look at the diagram and see in which direction is this force F12. Now from the diagram it is clear that F12 is in the direction of this unit vector R cap 21. You can see here R cap 21 is from, in which direction? From Q2 to Q1, in the direction of this force F12. So F12 is in the same direction as the unit vector R cap 21. So we shall use this R cap 21 for the force F12. So the direction for this vector force F12 will be R cap 21. Similarly, for the direction of this force F21, now the magnitude is the same, which is 1 by 4 pi epsilon naught Q1 Q2 by R square. So the magnitude is the same. Now we have to find the direction. Again we look at the diagram. In which direction is the force F21? You can see that the unit vector R cap 12 is in the direction of the force F21. So we can use this unit vector R cap 12 to specify the direction of the force F21. So what we have here, magnitude F21 is equal to the magnitude of the force and the direction, which is given by this unit vector R cap 12. Okay, so this is Coulomb's law in vector form. So we only have to draw the unit vector R cap 12 and R cap 21, and we see the direction of these two forces, in which direction they are. Now these are for like charges. Coulomb's law in vector form for like charges. So we have positive, if Q1 is positive, Q2 is positive, we'll have this case. Or if Q1 is negative, Q2 is negative, then we'll have to write Coulomb's law in this way. If the charges, they are unlike charges, one is positive, one is negative, or one is negative and one is positive, then Coulomb's law in vector form will be different. Alright, so if we have unlike charges, what will be the force? What will be the nature of the force? So if we have unlike charges, then the nature of the force will be attractive. So here, if we have Q1 to be negative, Q2 to be positive, this force F12, the force experienced or exerted on the charge Q1 due to the charge Q2 will be in which direction? In this direction. So this will be a force of attraction. Similarly, the force exerted on Q2 due to the charge Q1 will be attractive in nature and will be in this direction. So F21. So you can see here, if these are unlike charges, the force, they are attractive in nature. Now we have already drawn this unit vector R cap 12 and R cap 21 to specify the direction. Now this F12 is read as force on charge Q1 due to charge Q2. F21 is read as force on charge Q2 due to charge Q1. So we'll express this in the vector form, F12. Now the magnitude, again it's same, 1 by 4 pi epsilon naught Q1 Q2 by R square. What will be the direction? Again, you look at the diagram. Now here F12 is in which direction? R cap 12. See, R cap 12 is in the direction of the force F12, in the same direction.